Hey, in this video I'm going to be questioning a couple aspects of our response to Bell's theorems. First of all, I'm going to be questioning the idea that locality and determinism are equally weighted properties of the universe, or that locality is more important, and I'm going to be arguing that we actually should have gone for non-local determinism if tasked to choose between the two. The second thing I'm going to be doing here is I'm going to be arguing that actually the quote-unquote non-local fork of Bell's theorem is not actual non-locality, whereas the deterministic fork of Bell's theorem is actual non-determinism, so that we're not actually really pressed with a very difficult choice here. Actually, maybe I'll just start with the second argument. What Bell's theorem says on one side seems to look like actual indeterminism. It really does break the notion of determinism if we want to have locality. On the other hand, we are not actually breaking the idea of locality if we choose determinism. Non-local is a translation of the fact that there has to be information transfer faster than c, according to Bell's theorem. And the problem with this is, yes, in the context of relativity theory, motion faster than c can be considered non-local. In any other context, this is wrong. And the issue, even though this might be called nitpicking, the issue is that Bell's theorem is implying that no matter what fork we take of the theorem, relativity is going to have to go. So we already know that parts of the theory we build are going to have to be non-relativistic. So why would we continue interpreting faster than the constant c as immediate? It's a really simple point, but it's important in its implications of whether or not these are actually two equally basic properties of the universe. Secondly, I would argue that even if we get a real fork between determinism and locality, we should be going the non-local deterministic route for reasons of philosophy of science. From the perspective of science, it may be true that locality and determinism are two equally important properties of the universe. But from a meta-scientific perspective, one of these has a big role in this register, one of them doesn't. Determinism is actually a theory of what it means to have an explanation. And when we're dropping it, it's not like any of the typical paradigm shifts that Kuhn describes. I mean, in a way it is, because these are all really total shifts in the meaning of science that redefine science. But the issue here is they normally are shifts in favor of a paradigm that has offered a better explanation. And the standards of what it means to have an explanation are actually relatively shared. This is actually the first time we've really modified our notion of explanation in order to make it fit the content of our theories. From a deterministic perspective, quantum dynamics is not a complete explanation of the quantum realm, which is why we had to drop determinism in the first place. Also, in addition to those two things, I just wanted to give some historical context on the origins of Bell's theorems and why they may have been interpreted this way. Interestingly enough, Bell's analysis of his own theorem was more similar to what I am saying, where he actually viewed Bell's theorem as an argument for non-local determinism. He was a Bohmian, although he believed in a genuine non-locality, which I don't think is even really implied or forced by Bell's theorem. But this theorem was actually an update to a theorem of von Neumann's that completely disproved the idea that physics could be deterministic. It wasn't just a fork with locality. And this theorem about the EPR paradox turned out to be wrong. There was an error in it that wasn't spotted for years that Bell was actually correcting. But the acceptance of this flawed theorem for years and years, the mistake was actually first noticed by a woman, but it wasn't taken seriously because she was female. It actually shifted the scales beforehand. Plus, even before von Neumann's result, they already were preferring non-deterministic theories. So, non-determinism, it's pretty much always been preferred by the founders of quantum mechanics. There are reasons for it, but it's not really a result of Bell's theorem, either historically or theoretically.